Okay, I'm good. I'm good. The cable landing site, that's an important thing. Now, I guess I want to form a better question. Let's I need some background information before I form the question I want to form.
Okay.
I'm getting excited here. This is a
Good.
lot of
This
fun,
is cool
Steve.
stuff. No, like I say, it's a wonderful technology. Again, it's something that a lot of people kind of know is there, but don't really know about it because it does work so well. It just sits in the background and creates all this capacity.
Okay, so here we go. We're going to educate me, and you can boil it down to like I'm a 3-year-old if you want. So, the first question I have is what is actually like, how do you refer to the packet of data? Is that like a photon going through light? Is it an electron? Like, how do you refer to, like, let's say we're on a call right now, and let's pretend we're
Yeah.
on two different land masses. Let's pretend you're in the UK and I'm in the US.
Yeah.
And data is, entering in through the camera, hitting the camera lens, getting turned into data, going out through, my router, my ISP, and then what happens after it. Like I'm very familiar with the modem that's in the
Sure.
office, but then what happens when it hits that modem and then goes off into the internet? How does it get to
Okay.
you?
So why don't we start with, you'll be just for today, because I really don't know where you are. I'm on the East Coast and you're in Europe, just to make it up, right?
Okay, I'll be in Europe.
So, and we got a video link and an audio link going, right? So you're basically you're taking information off your screen, you're taking your voice, you're digitizing it, right? You're forming packets. Those packets are then ultimately given an IP address, right? So it's typically starting as Ethernet, they've been encapsulated with IP, and off they would flow into the grand internet, right? With an address that says, you want to talk to me, right? Now, in reality, with Zoom, what you're doing is you're talking to Zoom. Zoom's making the connection in the background, and then Zoom's finding me. So we're not directly connected in that sense, but it basically works the same way. So you're generating packets with addresses that get routed to me, right? So they start as an electrical signal. Someplace within the network, they will be turned into an optical signal. So you'll do an optical electrical conversion, right? You'll take the electrons coming in, you'll use it to modulate light. That modulation on the light is that information that you want to convey. That would then go down into this, in the case of this long transatlantic cable, gets dropped in, let's say, in just outside of New Jersey, transits across the Atlantic, comes out, let's say, on the UK, and goes back into an electrical signal, and it finds its way to you, and vice versa, right? So same thing happens for me. My image, my voice, digitized, put into packets, given an IP address that finds its way to you.
Brilliant. Yes, you just made me smarter. Thank you.
Sure.
That's, I'm a big nerd. I was curious to how like electricity turned into pixels. And so I spent like a year hunting
Oh
down
yeah,
every
yeah, yeah.
step. I learned about transistors and, how does it come from the power station and step down through the transformers and then go into the computer and go through and then become data. And so I hunted all of that down, but I never did that variation with how data flows across the world. I just knew it was like a beam of light.
Yeah, yeah. Well, I mean, that's most people's experience is, either the wireless device, in which case you've got a radio frequency that's been modulated, and that's how you're getting connected to a tower or a Wi-Fi access point, or it's, a physical Ethernet cable. And again, it's electrons at that point, right? That RJ45, which is the same everywhere in the world. That's what most people's experience is. But the reality is, generally, as soon as it gets inside of the network to the local central office, in some cases, if you're in an office building, maybe down in the basement or even a local wiring closet, you're going to convert it into light. You're going to do this optical, electrical, optical conversion right there, because the losses on fiber are very, very low, right? So you don't spend a lot of energy once you get the things into an optical format, and they're also very high capacity. So when you think about, data rates, for example, right? So most people probably are okay with saying a gigabit, right? That's probably about the fastest you typically experience. Most people for, a Cat 5, 6Y or in your house, that sort of thing, you might say, I got gigabit Ethernet. By the time you get into the optical domain, and this is actually one of the changes that Ciena has driven over the last 25 years, is we first introduced a technology called wavelength division multiplexing, where you put multiple colors of light on the same fiber. and then you run all those parallel colors through one amplifier. Right? So that's dense wavelength division multiplexing. And we also, I know we did that, by the way, about 1995. So that's, very old technology, very well established now. Around 2010, we also introduced this coherent detection model where you actually use a laser at the receiver to measure the incoming laser, right? And lasers being very precise, you get a lot of information out of it that way. And so when you look at the rates on the optical lines, remember you got this gigabit electrical in your hand is pretty typical. By the time you get to optical rates, you're talking, 100 gigabits, 200 gigabits, 400 gigabits. The stuff that we're now shipping is 800 gigabits, right? And that's per wavelength. Then you multiply by how many wavelengths it can generate. And so, a single optical fiber today, in general, you can think about 20 to 30 terabits on that individual fiber, right? I mean, that's just a tremendous amount of capacity. And it's been that deployment of all this capacity and connectivity over the last, decade or so, that's really put the kind of the connectivity platform in place. That's why we can do the things we're doing right now. If you can imagine what the world would be like if we were trying to do this kind of connectivity, this kind of communications on a dial-up service, right? If you go back to the beginnings of the internet, it'd be game over, right? You have to have this kind of capacity and connectivity built right into the infrastructure to make all this work the way we want. So, I think the whole industry is, fortunate, the technologies that we pioneered got widely adopted, widely deployed. And so we've been able to push huge amounts of capacity out there. And that's what, the digital economies are really, thriving with right now.